In this video, we'll break down the concept of machine learning in the most straightforward and down-to-earth way possible. Whether you're new to the topic or just looking for a refresher, we've got you covered. So let's get started. At its core, machine learning is all about teaching computers to learn from data and make predictions or decisions. Think of it as training a computer to perform tasks by learning from examples. Just like how we humans learn from experience and adjust our actions accordingly, machine learning uses some step-by-step instructions, or what is called algorithms, to learn from data and become better over time at doing so. Computers can be made to learn from data and improve in many ways. But that notwithstanding, there are essentially three main types of machine learning. These are supervised learning, unsupervised learning, and reinforcement learning. Now let's talk about them one by one. Number one, supervised learning. This is like teaching a computer with a teacher or a supervisor by its side. In supervised learning, you provide the coded instructions or algorithm with the labeled data, meaning you tell it the correct answers beforehand. The algorithm then, by finding patterns in the data that link input or features to output, that is to say, the labels you provided, it then uses these patterns to make predictions on new, unlabeled data which is made up of only the input or features. In reality, supervised machine learning would normally be applied on emailing platforms like Yahoo, Microsoft, Gmail, and many more to sort of filter unwanted messages as spam when such messages come into your email account. Another application would be to use supervised machine learning to predict what the prices of houses would be in the future. Number two, unsupervised learning. Unsupervised learning is more like letting the computer explore on its own without explicit supervision. Here, the algorithm works with unlabeled data or features and tries to find hidden patterns or structures. It's like discovering similarities or groupings within the data without explicit guidance. Since unsupervised machine learning algorithms are essentially able to identify unusual patterns that deviate from the norm, they can be used in many fields and applications. For instance, they can be used to collect and cluster similar customer behaviors for targeted marketing strategies and product offerings to specific customer segments. Unsupervised machine learning can also be applied to detect credit card transactions, identify manufacturing defects in products, etc. Number three, reinforcement learning. Reinforcement learning is like teaching a computer how to play a game. The algorithm learns by interacting with an environment and receiving rewards or penalties based on its actions. Over time, it figures out the best strategies to maximize rewards. It is inspired by behavioral psychology, where learning is achieved through trial and error interactions with the environment. Reinforcement learning also has many applications. For instance, reinforcement learning has achieved significant success in training agents to play games like chess, Go, and video games. Reinforcement learning is applied in robotic systems to perform tasks like picking objects, walking, or flying. Reinforcement learning is also being applied to produce self-driving cars that can learn to navigate complex road environments and make safe driving decisions. So as you can see, machine learning generally has many areas of application. In fact, machine learning has found its way into countless aspects of our lives, often without us even realizing it. Here are a few examples. Recommendation systems. Ever wonder how streaming services such as Netflix, Amazon Prime Video, and YouTube suggest shows or movies you might like? That's machine learning in action. These systems learn from your viewing history and preferences to make personalized recommendations. Medical diagnosis. Machine learning can analyze medical data to assist doctors in diagnosing diseases, such as identifying potential tumors in medical images. Language translation. Translation apps and services use machine learning to convert text from one language to another, often improving over time as they learn from more examples. Financial analysis. Machine learning algorithms can analyze financial data to predict stock prices, detect fraud, and optimize investment strategies for profits. To better understand how machine learning works, let's look at its key components. Number one, data. Data is the fuel that powers machine learning. It can be anything from numbers and text to images and videos. The quality and quantity of data play a crucial role in the success of a machine learning model. Number 2, features. Features are the characteristics of the data that the algorithm uses to make predictions. For example, if you're predicting house prices, features could include the number of bedrooms, square footage, and location. Number 3, model. The model is the heart of machine learning. It's the step-by-step instructions or algorithm that learns from the data and makes predictions. Just like a recipe, the model takes in features, processes them, and produces an output. Number 4, training. Training is like teaching a computer. You provide the model with labeled data, and it learns to make predictions based on the patterns it discovers. It's a bit like showing a dog a different breed until it can recognize them on its own. Number 5, testing and evaluation. After training, you test the model's performance on new, unseen data. This helps you understand how well the model is likely to perform in the real world. Evaluation metrics like accuracy or error rate help quantify the model's performance. Now you might ask, what kinds of challenges machine learning is currently facing and what its future holds? Well, while machine learning has opened up incredible possibilities, if one were to be honest, it is not without its challenges. One major hurdle is the need for large and high-quality data sets. Without sufficient data, models may not generalize well to new situations. Privacy and ethical concerns also come into play, especially when dealing with personal data. Looking ahead, researchers are working on making machine learning models more interpretable and transparent. This means understanding why a model makes certain predictions, which is crucial, especially in sensitive domains like healthcare. And there you have it, a simple and down-to-earth explanation of machine learning. Remember, machine learning is about teaching computers to learn from data, just humans learn from experience. Whether it's making recommendations, diagnosing diseases, or even driving cars, machine learning is shaping our world in remarkable ways. So next time you use a recommendation system or see a self-driving car, you'll know that it's all thanks to the magic of machine learning. Thanks for watching. If you enjoyed this video, hit that like button. And don't forget to share and subscribe for more simplified and exciting insights into the world of business and technology. Thank you for joining us, and until next time, happy learning.